class we were discussing about functions in C, and we saw that uh, a function is just like a mathematical function, and that will be translated to a C programming language statement. For example, if you have something like f of x is equal to x squared, the equivalent set of uh, C programming statements will be something like first you will provide the return type, which is actually int, and then the name of the function, here it is f, and then the arguments to the function or the parameters to the function with the corresponding data type, which will be int x. And here what we are doing is we have to return x squared, right? So we write something like return x times x. And in the main function, we will normally write it as void main. And here we declare a variable called x, and maybe another variable called square. Then we read the value of x, which is scanf percentage uh, scanf percentage d and x. Then uh, we call the function or we invoke the function, something like sqr assigns the returned value by the function will be captured in the variable sqr. So sqr assigns f of x. So then we print the value of sqr, right? That is print the percentage d backslash n sqr. So uh, this will essentially uh, this is a program to find the square of a number which is read from the keyboard, and the squaring part has been converted to a function, right? And then we saw the case of function prototype. This is what you call the function definition. This is the function definition, and this is what you call the function invocation or function calling. And normally you write a function prototype also, which is something like int f int. So this is what you call the function prototype. After that there is a semicolon. This is the function prototype. And this function prototype tells the compiler that in the program there is a function called f, function named f, and it is returning an integer, and it is taking only a single argument of data type int that will be that will be defined somewhere in the program. So this is actually a program for finding the square of a number, right? And then we discussed about the various uh, parameter passing mechanisms, not actually the various parameter passing mechanisms, but the way in which a parameter will be passed to a function. For example, normally everyone knows that we are starting the execution of the program from the main function, right? This main also is a function. That is why you can see an opening bracket and a closing bracket, and it is taking no argument at all. There is no parameter passed to this main function. Later we will see how we can pass parameters to the main function, but for the time being, there is no parameter passed to this main function. And the return type is actually void. That means it is not returning any value back to the calling program. So we will discuss about all these things in detail later, but let's try to understand how exactly this parameter is being passed from uh, one function to another. So we are in the main function. We have declared two variables here. We have x, maybe defined at location 7000, and then we have sqr. This is defined probably at location 5000, and then we are scanf percentage d ampersand x. So we are reading a value from the keyboard to the variable x, something like, suppose the user has entered the value 10, then the value 10 will be stored in this location, right? 7000. Now we are invoking this sqr f of x. So essentially here we are invoking something like SQR assigns f of x. What is x here? It is 10. So this is how we invoke, this is how this is translated, or this is how this statement is executed. SQR assigns f of 10. So we move to this function uh, definition here. Here you have f is the name of the function f, and int x. X is a local variable there. So x is a x, not really a local variable. X is a parameter there. So in this case, we if we have a parameter here, there will be another location in which that variable uh, will get the storage. For example, in location 3000, this x is actually the parameter to the function f, and this x will get the value 10. So this is how the parameter passing mechanism actually happens. We are not going to use the x declared, we are not going to use the x declared in this main function. Rather, we have a new x which is uh, specific to this function f, and that x will get the value which was contained by uh, this thing, that is the 10 value. The value 10 will be allocated to this x, which is at location 3000. Then what we are doing is return x times x. What is x here? It is 10. 10 times 10 is what? 100, right? So this function returns the value 100, and the value 100 will be captured in the variable SQR. Captured in the variable SQR. SQR is local to this main function, right? So the value 100 will occupy this location. And finally, we are printing printf percentage %d backslash n SQR. So this is uh, this will print the value of SQR, which is nothing but 100, right? So I think we discussed this thing in the last class. So let's continue with the parameter passing mechanism. Let me write another program here. Suppose I have something like hash include stdio.h should be there anyway. stdio.h is there. Then I am defining a function called probably I'm defining something like void chain. This void means it is not returning any value. It is not at all returning any value back to the calling function. That is why it is void. Otherwise, if it was int, then it is mandatory that this function should return an integer value. There should be an explicit return statement in that case. If it is void, there is no need of an explicit return statement inside this function. That means it is not returning any value at all. Int x, and what I am writing here is say x assigns x plus 1, right? So there is no explicit return statement here. That is the meaning of this void. Now you may understand why we are using this void main. Main also is a function, and it is from the main function that the sequence of execution gets started, and it is not returning any value. There is no return statement in the main function, right? That is why we normally write void main. If it is returning some value, then we have to write the corresponding return type. For example, you can also write something like int main. In main, this is also fine, and you are doing a lot of processing here. And after that, at the end of the function, there should be some. It should return some integer value, probably some return 0. Some of the students have written programs like this. Now you may understand why what is the difference between in main and void main. The void main also does the same thing. Here you can write it something like void main. You will have all these statements here except this return 0. So this is the only difference between in main and void main. Many people actually prefer to write in main instead of void main, but whatever you would like to do, just go with that. Now let's get back to this program. So I have written something like a void change index, and x is the parameter which is passed to this function, and I am changing the value of x by adding it with a 1. That is, it will be simply implemented with 1, right? Now I am writing the main function. I am still writing this void main, and I have a say something like I have in x here. Probably I am reading the value of x, or well, I can easily write it if I am not reading that. I am writing x of 10, then I am calling the function change with x, and then I am printing the value of x. Print the percentage d backslash n x. That's it. So what should be the output of this program? Can you write in your chat window what will be the output of this particular program? What will be the output? When you're writing the chat window and checking your comments. Uh, okay, Akash, it's 10, right? Okay, so then write 10. Okay, yeah, Ahmad Abdul Wahab. Okay, 10. Yeah, Deepak, 10, right. 10 is the correct answer. So let's once again analyze this program. Always the execution starts at main, right? So what we do is we have a index of instance. So somewhere in memory, x is a variable, integer variable, may be defined at location 2500, and it has a value 10, right? Now change x, that is we are invoking change 10. So we go to this change function with a parameter x, and it is going to get a value 10, right? But the problem is that this x is something new. Whenever you have a parameter here, that will have another that will occupy another memory location, probably 7000, and it will get the value 10, which is passed from this main function, right? So it is getting this 10. Now what I am doing is x assigns x plus 1. So which x am I changing? Am I updating the x which is belonging to this change function, right? So I am updating this value to 11. This will be 11, right? So the change function is over. It is not returning any value. That is why I cannot capture any returned value here. It is not returning any value at all. Finally, I am performing this printf statement, which is printf percentage d backslash x. So which x am I printing? The x which is local to this main function, right? That is x which is local to this main function has the value 10 itself, right? That is why you can see that the value which is printed will be nothing but 10. Correct? I hope all of you understood this. Uh, and this kind of a parameter passing mechanism, which is actually followed by C, is called passing by value mechanism. This is what you call pass by value. Pass by value. So this pass by value means instead of passing the entire variable, we are just passing the value of that variable to this function. Here you have this x. We are not actually passing the entire variable which is stored at location 2500. Rather, we are just passing this value. What is the value here? It is 10, and that value will be passed to this function change, right? So the x in the uh, x, which is the parameter to the change function, will not be same as the x which is actually there uh, in the main function. So the variables are actually different. The only thing is that the parameter x in the change function will get the value of the x in the main function. So we are just passing the value only, and this is what you call pass by value mechanism. So we are not passing the variable, rather just a copy of the value of the variable. That is the only thing which is passed. Later we will see another mechanism called the pass by reference. That I think we can see when we learn about pointers. there is another mechanism in C, but the default mechanism in C is C for parameter passing is pass by value mechanism. Does everyone understand what pass by value mechanism is? Shall I check your comments? Pass by value mechanism. So, yeah, right. So, the definition for pass by value mechanism is that whenever there is a function invocation, uh, rather than passing the entire variable itself, we are just passing the value of that variable to the new function. For example, here in the main function, you have this variable x, and we are not actually passing the variable x to the function change. Rather, we are passing the value of x in the main function. What is the value of x here? It is 10. We are simply passing this 10 to the argument of the change function. We are not passing the variable, but we are just passing the value of that variable to the change function. Uh, so that is why the variable in change function, which is actually depicted here, right? The variable x in change function will get the value of the variable x in main function. What is the value of variable x in main function? Which is 10. So the value will be given to the parameter x in the change function. That is why we call it pass by value mechanism. So, is it clear? Okay, thank you. So now let me slightly update this program. You have to tell me what the output will be. So I am just uh, changing the name of this variable. Okay, it should be x. This is x. And here what I am doing is, instead of this x here, I am writing a. This is a change that I am making. I am writing a, and here it is nothing but a assigns a plus 1. Now my question is whether my program is syntactically correct or not. And if it is syntactically correct, what exactly will be the output? Is my program correct, or will the compiler raise an error here? Once again, I am checking the comments. No comments so far. Return type, no. Output remains correct. Okay, ring says syntax is correct and output remains same. Okay, neither says no error. Okay, so let's see. Let's once again analyze this program. We start from main. We have index of 10, right? So that means somewhere in memory we have this x variable. I will write using the same color. Somewhere in memory you have the x variable, probably at location 1000, and the value of x is nothing but 10, right? Now we are calling this change x. Change x means change 10. So here you have this a variable, and maybe this is at location 7000, and this a variable is going to get the value 10, which is passed from this main function, right? So this is 10. Now what I am doing is a assigns a plus 1. A assigns a plus 1 means this a will be incremented by 1 to produce 11, right? 11. Now the function is over. There is no return type. That is why there is no return value. That is why it is void, right? Now this change function is over. Finally, this printf percentage %d backslash n x. Now that you can see is I am trying to print the value of x. What is the value of x? It is 10. So the value that is printed will be nothing but 10. 10 will be the value that is printed. I hope this portion is uh, understood to everyone. This is not really something that we have to find really difficult to understand. The only thing that you need to have in mind is this variable mapping, like in the memory or this memory mapping. In the memory, for each variable, there should be some sort of storage allotted, and that storage should contain these values. So let me once again, slightly change this program. What I am trying to do is, I am trying to, yeah, let me erase all these things. Let me uh, let me change this to this void to, I am changing to this int. Int change int a, and here what I am doing is I am adding an extra statement, return a, right? Now what should be the output of this program? Can you write what exactly the output of this program will be, or will there be any sort of uh, error, or will there be any change in the output? Can you write that? Yeah, everyone right? It's 11, right? Okay. Okay, the Akash, Deepak, okay, everyone writes into 11. So once again, let's analyze this thing. Once again, we will use the memory mapping method. We start from this main index assign step. So we have this x, right? And this is stored in location, probably some 2000. And this is going to have the value 10. Now we are calling this change x. Uh, change x. Uh, so we are coming here. And here we have this int a, right? A is in some location 3000 probably, whatever, and it is going to get the value 10, which is passed from this main function, right? Now what are we doing? A assigns a plus 1. I am changing the value of a to 11. Okay, I'm changing the value of a to 11. I'm changing the value of a to 11. Now return a. The value 11 is returned back to this main function. The value 11 is returned back to this main function. But what happens to this returned value? Is it captured in some variable, or is it printed here? The return value, there is a value which is returned to this main function, but we are not capturing it, or we are not storing it anywhere or in any variable. That returned value is lost in the main function. There is a value 11 which is returned, but that is not actually captured in any variable at all. Rather, we continue with the next statement. What is the next statement? This is the next one, right? Printf percentage d backslash and x. What is the value of x? Here it is 10. So the value printed here will be 10 only, not 11. The value printed will be 10. The value 11 was returned back to its main function, but it is lost. It is not captured. So rather, what we are doing is we are simply printing the value of x, and that is only 10. So the answer will be 10. So do you understand? Do you get the real way in which this program is behaving? Right. നോടി നോക്കിക്കോളൂ, ഞാൻ പറയാം എവിടെ. ഇവിടെ എന്താണ് ആക്ച്വലി ചെയ്തത്? മെയിൻ ഫംഗ്ഷൻ ഇവിടെ നിന്നാണ് നമ്മൾ സ്റ്റാർട്ട് ചെയ്യുന്നത്, അല്ലെ? മെയിൻ ഫംഗ്ഷനിൽ സ്റ്റാർട്ട് ചെയ്യുന്നു. ഇവിടെ എക്സ് എന്നുള്ള വേരിയബിൾ ഉണ്ട്. എക്സ് എന്നുള്ള വേരിയബിൾ പ്രോബ്ലി ഇൻ സം ലൊക്കേഷൻ 2000-ലാണ്. ഇതിന് 10 എന്നുള്ള വാല്യൂ ഉണ്ട്. നൗ വി ആർ കോളിംഗ് ചേഞ്ച് എക്സ്. ചേഞ്ച് എക്സ് എന്ന് വെച്ച് കഴിഞ്ഞാൽ ചേഞ്ച് എന്നുള്ള ഫംഗ്ഷനിലേക്ക് പോകും. അവിടെ പാരാമീറ്റർ എന്ന് പറഞ്ഞാൽ എ ആണ്. എ ഒരു ലൊക്കേഷൻ സം 7000-ലാണ് ഉള്ളത്. ഇതിന് ഈ പാസ് ചെയ്ത് കൊടുത്ത വാല്യൂ കിട്ടും, 10 എന്നുള്ള വാല്യൂ കിട്ടും. right? A assigns a plus 1. അപ്പോൾ 10 ഉള്ള വാല്യൂ മാറിയിട്ട് 11 എന്നുള്ള വാല്യൂ ആയിട്ട് മാറും. This is now 11, right? Now return A. A റിട്ടേൺ ചെയ്യും, അതായത് 11 എന്നുള്ള വാല്യൂവിനെ ഇങ്ങോട്ട് റിട്ടേൺ ചെയ്യും. ഇങ്ങോട്ട് റിട്ടേൺ ചെയ്യുന്ന വാല്യൂവിനെ നമ്മൾ എവിടെയാണ് ക്യാപ്ചർ ചെയ്തിരിക്കുന്നത്? ഇതൊക്കെ ഒരു വാല്യൂ വന്നു. ആ വാല്യൂവിനെ നമ്മൾ എവിടെയെങ്കിലും നമ്മളിത് ക്യാപ്ചർ ചെയ്തിട്ടുണ്ടോ? നമ്മളതിനെ എവിടെയെങ്കിലും സ്റ്റോർ ചെയ്ത് വെച്ചിട്ടുണ്ടോ? ഇല്ല. ഈ വന്നിരിക്കുന്ന വാല്യൂവിനെ ഇവിടേക്ക് വന്നു എന്ന് മാത്രമേ ഉള്ളൂ. നമ്മളതിന് അത് ലോസ്റ്റ് ആയിപ്പോയി. അത് പ്രത്യേകിച്ച് സ്റ്റോറേജ് ഇല്ല, അല്ലെങ്കിൽ നമ്മളതിന് ഒരു വേരിയബിളിലും ക്യാപ്ചർ ചെയ്തിട്ടില്ല. ഇനി ക്യാപ്ചർ ചെയ്യണമെങ്കിൽ എന്തായിരുന്നു വേണ്ടിയിരുന്നത്? സംതിങ് ലൈക്ക് സം എക്സ് അസൈൻസ് ഓർ സം ചേഞ്ച് എക്സ് എന്നൊക്കെ കൊടുക്കണമായിരുന്നു. അങ്ങനെയാണെങ്കിൽ റിട്ടേൺ ചെയ്ത വാല്യൂ എക്സ് എന്നുള്ള വേരിയബിളിനകത്ത് വന്ന് സ്റ്റോർ ആകുമായിരുന്നു. പക്ഷെ ഇവിടെ അത് സംഭവിച്ചിട്ടില്ല. ഇവിടെ ആക്ച്വലി സംഭവിച്ചതെന്ന് വെച്ചാൽ ചേഞ്ച് എക്സിനെ വിളിച്ചു, ഈ പറഞ്ഞ കാര്യങ്ങളൊക്കെ ചേഞ്ച് എക്സിനകത്ത് ഈ പറഞ്ഞ കാര്യങ്ങളൊക്കെ സംഭവിച്ചു. അതൊരു വാല്യൂവിനെ റിട്ടേൺ ചെയ്തു. ആ റിട്ടേൺ ചെയ്ത വാല്യൂവിനെ നമ്മൾ എങ്ങും പിടിച്ചിട്ടില്ല, എങ്ങും സ്റ്റോർ ചെയ്തിട്ടില്ല. അതുകൊണ്ട് അത് എന്ത് സംഭവിക്കും? അത് ലോസ്റ്റ് ആകും. പിന്നീട് നെക്സ്റ്റ് സ്റ്റേറ്റ്മെന്റ് എന്താണ്? പ്രിന്റ് ഓഫ് പെർസെന്റേജ് ബാക്ക് സ്ലാഷ് എക്സ്. എക്സ് എന്ന് പറയുമ്പോൾ ആ എക്സിനെ പ്രിന്റ് ചെയ്യും. വാട്ട് ഇസ് ദ വാല്യൂ ഓഫ് എക്സ് ഹിയർ? ഇറ്റ് ഇസ് 10. സോ ഇറ്റ് വിൽ പ്രിന്റ് 10 ഓൺലി. ഇത് മനസ്സിലായോ? So is it too confusing for you? Okay, and we are right. What about others? Is it too confusing for you? Okay, Agash, right. Deepak, right. I hope all of you understood this. This should not be something hard for digestion. ഇവിടെ ആകെ നോക്കേണ്ടതെന്ന് വെച്ച് കഴിഞ്ഞാൽ you have to just check the memory map. And now, okay, in order to make it more understandable for you, I am changing this program a little more. It should be there. I am changing this in such a way that I am writing it like, instead of this change x assigns change x. So what is the difference that you will feel now? X assigns change x. What will be the output now? Yeah, it should be it should be 11, right? So let's once again analyze this program. We have a we have a thing, right? So initially we are starting from this main. We execute this line, that is index of 10. That means somewhere in memory a variable is formed and the value is 10, right? Now we are calling the function change x. Change x means we go here and there is a variable called a. It is getting the value 10 and it is a location, some other location 7000. What we are doing is a assigns a plus 1. That is the value 10 will be replaced with 11, right? Now return a. Okay, the value 11 is returned. If it captured in some variable here, yes, it is captured in the variable x. It is captured in this variable x, right? That is, whatever returned by change x is assigned to the variable x. What is returned by this change x here? It is 11. 11 is assigned to the variable x. That means the variable x gets the value 11 here, right? Whatever returned by this change will be assigned in the variable x. So x gets the value 11. Now we are printing this percentage d backslash n x. So the result will be actually 11. So do you understand this concept? Yeah. ഒന്നുകൂടെ പറഞ്ഞു, എനിക്ക് ഒന്നുകൂടെ പറഞ്ഞ ഗ്ലോബൽ ആക്കുന്ന കേസ് അല്ലേ? ഒരു ഫംഗ്ഷനിലെ വേരിയബിളിനെ വേറൊരു ഫംഗ്ഷനിൽ ആക്സസ് ചെയ്യാൻ പറ്റില്ല. പറ്റും, അതൊരു ലൈക്ക് നമുക്കത് പോയിന്റേഴ്സ് ഉപയോഗിച്ച് മാത്രമേ പറ്റത്തുള്ളൂ. പക്ഷേ അല്ലാതെ നമുക്ക് ഗ്ലോബൽ വേരിയബിൾസ് ഉണ്ട്, ഞാൻ അതിലേക്ക് വരാം. അങ്ങനെ വേണമെങ്കിൽ നമുക്ക് വേരിയബിൾസിനെ ഷെയർ ചെയ്യാൻ പറ്റും, നമുക്ക് അതിലേക്ക് വരാം. അല്ലാതെ ഒരു ഫംഗ്ഷനിലെ വേരിയബിളിനെ വേറൊരു ഫംഗ്ഷനിൽ ആക്സസ് ചെയ്യാൻ പറ്റില്ല. ഞാൻ ഒരു എക്സാമ്പിൾ എഴുതി കാണിക്കാം. സോ ലെറ്റ് മീ റൈറ്റ് അനദർ എക്സാമ്പിൾ ഹിയർ. I have anything like, say I have hash include stdio.h. Then I have a probably void. What is the meaning of this void? It is not returning any value at all, right? Void true. Say you have a I am declaring a variable here in x, or rather I'm not declaring anything here. Uh, I have int x here. What I am doing is printf percentage d backslash n x, right? And I have this void main here. And here what I am doing is I have this probably index assigns 10, and I am calling this foo. Yes. So what is the output that I am going to get when I execute this program? What should be the output? Nobody is writing anything. Why? What should be the output that I am going to get here? It's a very simple function, right? Okay, John, I'm right. 10. It's 10. It's nothing very complicated. So once again, we start from this main function. You have this x here. Okay, stored at location 7000. It is getting the value 10, and I am calling this foo. Once I go to this foo function, I have this variable x here, and this x is stored at location probably some 6000, and the value which is passed from this main function will be allocated to the parameter x here, that is 10. Now what I am doing is printf percentage d backslash n x. Which x am I printing? The x which is there in the foo function, right? So it will print the value 10. That's for sure. Now what I am changing is I'm trying to change this program a little more. What I am doing is I'm just avoiding this index. Now what should be the output? Now the foo function does not accept any parameter. It is not going to have any parameter at all, right? And still it is printing with x. So what should be the output of this program? Can you write? Can you write in the chat window? We can access that, right? Okay, let's analyze this program once again. I have this main function, and I have this variable x, right? And it is going to have the value 10. Sorry, there is another problem here. I cannot actually call it in this way because the foo function is not accepting any parameter, so I cannot write any parameter here. I am simply calling this foo function, right? Without any argument. As the foo function is not accepting any parameter at all, I cannot pass any parameters here, right? The signature should be the same. So I am invoking this foo function here, and I read this foo function. There is no parameter at all, and what I am trying to execute is this statement: printf percentage d backslash n x. So what is x for this foo function? It doesn't know what this x is, right? It doesn't know. It doesn't exactly know what this x value is. There is an x variable which is local to this main function, and that is not accessible inside this foo function at all. So this particular statement will result in an error saying that it does not understand what exactly this x is, or it will say that x is undefined. So do you understand this part? So this will result in an error. This will result in a compilation error saying that x is undefined. That is because in the foo function, it does not understand what exactly this x is. It doesn't know what x is. There is an x in the main function, but that is local to the main function. It is not available or it is not accessible inside this foo function. So the output or the when you compile this program, it will result in an error. So do you understand? Yes, Akash, right. Now I am changing this program a little more. Here what I am doing is I am defining a variable called x, and I am assigning the value 20 here. So what should be the output of this program right now? This should be easy to uh, predict the answer, right? Yeah, right. Ahmed says 20. Correct. It is 20. Right. Why? Because as in the earlier case, in x of 10, it is here foo. Uh, we are calling this foo, and here we have another x, right? Another x means uh, maybe in another location you have this x variable, and maybe in 5,000, and I am giving a value 20 here, and what I am printing is the the value of the variable x, which is local to this foo function, so the output will be 20, right? So these kind of variables, or the variables which are defined inside a function, are called local variables. So this x is a local variable. The variables which are defined inside a function are called a local variables. This is also a local variable. And local variables are not accessible across functions. A variable which is local to a function cannot be accessed in another function, right? So these are called local variables, right? We will. On the other hand, we can declare global variables. Global variables are not local to any function. Rather, we will define it outside every function. So where can we define all these variables? So this is a local variable which I am actually uh, changing. Outside every function means I can define a variable here outside every function. That is, I can declare a variable int x assigns 30 here, int x assigns 30. So this is outside every function, right? It is not local to any variable. This is called a global variable, and global variables are shared for every function. Let's analyze the working of this program once again. Even though we say that the execution starts at main, there are a few other things which are processed before executing this main, and they are actually these statements. Like these are the different statements which will be processed before executing this main. So there will be hash include stdio.h that contains a lot of header file. Sorry, that contains a lot of prototypes, and then this int x assigns 30. And here what I am when I see this variable index when I see this variable definition index assigns 30 somewhere in memory, I have that value 30, right? And that is for the variable x. Now I come to this main function. or main function is the first function that is getting executed. Main function, I call this foo, and when I go to this foo, I have printf %c backslash and x. And what is this x? X is global to every function. That means this function knows about this x, right? And it is global to, as it is global to every function, it knows what the value of x is, and it simply prints the value 30 here. And this is what you call a global variable. This is a global variable. We have local variable, we have global variable. Local variable means a variable which is defined inside a function. Global variable means a variable which has been defined outside every function. A global variable and its value can be shared across every function, whereas a local variable is local to that particular function only. It doesn't have scope outside that function. So do you understand the difference between global variables and local variables? Okay, that's Deepak, Nathan, right? Yeah. ഫംഗ്ഷനകത്ത് ഡിഫൈൻ ചെയ്ത വേരിയബിൾ ഗ്ലോബൽ ആവില്ല, അത് ലോക്കൽ വേരിയബിൾ മാത്രമായിരിക്കും. ഫംഗ്ഷനകത്ത് ഡിഫൈൻ ചെയ്തിട്ടുണ്ടെങ്കിൽ, ഫംഗ്ഷന് വെളിയിൽ ഡിഫൈൻ ചെയ്തിട്ടുണ്ടെങ്കിൽ മാത്രമേ അത് ഗ്ലോബൽ വേരിയബിൾ ആവത്തുള്ളൂ. ഇത് സാധാരണയായിട്ട് നമ്മൾ ഏറ്റവും പറഞ്ഞു മെയിനകത്ത് ഫോർ ലൂപ്പ് ഇട്ടാൽ ആ വേരിയബിൾ ഫോർ ലൂപ്പിന് പുറത്ത് ഉപയോഗിക്കാൻ പറ്റുമോ എന്ന് ചോദിച്ചു കഴിഞ്ഞാൽ ഇങ്ങനെയല്ലേ ഉദ്ദേശിച്ചത്? അതായത് സംതിങ് ലൈക്ക് ഏതാണ്ട് ഇതാണോ ഉദ്ദേശിച്ചത്? സംതിങ് ലൈക്ക് void means say int x for I assigns 0, I less than for x assigns 0, x less than 10, x plus plus, say I declare something like into y. ഇതല്ലേ ഉദ്ദേശിച്ചത്? into y assigns some 20, something like that. There are a few other statements. അതിനുശേഷം എനിക്ക് y assigns 30 എന്ന് കൊടുക്കാൻ പറ്റുമോ? ഇതല്ലേ ചോദിച്ചത്? ഇങ്ങനെയല്ലേ ചോദിച്ചത്? ഇതിന് ശേഷം സ്റ്റേറ്റ്മെന്റ്സ് ഉണ്ട്, ഇതല്ലേ ചോദിച്ചത്? കൗണ്ടർ വേരിയബിൾ ഈ മെയിൻ അകത്ത് എവിടെ വേണമെങ്കിലും ഉപയോഗിക്കാം, കാരണം ഇത് മെയിൻ്റെ ലോക്കൽ വേരിയബിൾ അല്ലേ. ഒന്നുകൂടെ ചോദിച്ചാൽ എനിക്ക് മനസ്സിലായില്ല, എങ്ങനെയാണ്? അതെ, ആവും, എക്സ്റ്റെൻഡ് ആവും. ഫോർ ലൂപ്പ് തീരുമ്പോഴത്തേക്ക് എക്സിന്റെ വാല്യൂ 10 ആയിട്ടുണ്ടാവും. എക്സിന്റെ വാല്യൂ 10 ആകുമ്പോഴാണ് ആ ഫോർ ലൂപ്പിൽ നിന്ന് എക്സിറ്റ് ആവുക. ഈ കണ്ടീഷനില്ലേ ചെക്ക് ചെയ്യുക, എക്സിന്റെ വാല്യൂ 10 ആകുന്നവരെ ഈ ഫോർ ലൂപ്പ് വർക്ക് ചെയ്തുകൊണ്ടിരിക്കും. ഇതിനകത്ത് പക്ഷെ വേറൊരു പ്രശ്നമുണ്ട്. ഞാൻ ഉദ്ദേശിച്ചത് ഈ ക്വസ്റ്റ്യൻ ആയിരുന്നില്ല. ഇവിടെ ആക്ച്വലി ഇത് ഇവിടെ ഇങ്ങനെ ഒരു ഇൻറ്റു y assigns 20 ഇങ്ങനെ കൊടുത്തേക്കുന്നില്ലേ, ഇത് ആൻസി സിയിൽ സപ്പോർട്ട് ചെയ്യുന്നില്ല. ഈ ആൻസി സിയിനകത്ത് വേരിയബിൾസ് എല്ലാം ആദ്യത്തെ ഫംഗ്ഷന്റെ ആദ്യം തന്നെ വരണം. അതായത് ഇങ്ങനെ കൊടുക്കാൻ പാടില്ല. ഇൻറ്റ് എക്സ് കോമ വൈ ഇങ്ങനെ തന്നെ കൊടുക്കണം ആൻസി സിയിൽ. നിങ്ങൾ ഉപയോഗിക്കുന്ന കമ്പൈലർ ആൻസി സിയുടെ കമ്പൈലർ അല്ലാത്തതുകൊണ്ട് ഇത് സപ്പോർട്ട് ചെയ്യുന്നുണ്ട്. ഇവിടെ ഇങ്ങനെ ഇതിങ്ങനെ മാത്രമേ പറ്റത്തുള്ളൂ. Is it clear, or I mean, have I answered your question correctly, or what? Okay, right. See, once again, I hope all of you understand the difference between global variables and local variables. Local variables means now I'm sorry. Okay. മാറും, അതാണ് ഞാനിവിടെ ആ ഒരു എക്സാമ്പിളിന് അടുത്തായിട്ട് ചെയ്യാൻ പോകുന്നത്. So the question was really good. Say something like So here I have defined int x assigned 30. I have already declared a global variable and I have initialized the value 30, right? So what I am doing is in the main function, I am changing the value of x to 10. Now what should be the output? And then after that I am calling this foo, right? So what should be the output? And when you check this thing, initially there is int x assigns 10, right? So somewhere in memory, x is there. Uh, in memory, there is the variable x with the value 30, right? And here it is the main function, and I am changing the value x in the main function. I am changing the value x to 10. Which x am I changing? It is the global variable, right? The global variable value has been changed to 10. So here we are getting the value 10. Now I am invoking this foo function. Inside the foo function, what I am doing? I am just printing the value of x. Which x am I printing? It is the global variable, right? So this will get the value, or this will print the value. Does everyone get this? Does everyone understand this? So if it's a global variable, every function can manipulate that variable. Every function can access the value of the variable. Every function can change the value of the variable. Everything is possible with a global variable. It is shared across all functions. But local variables are local to that particular function only. Inside that function, a local variable can be easily manipulated. But outside the function, uh, it is not possible at all. Ah, ah, ഇവിടെ ഇങ്ങനെ ഇതല്ലേ ഉദ്ദേശിച്ചത് ഞാനത് പറയാം സംതിങ് ലൈക്ക് ഇങ്ങനെ ഇവിടെ ഇന്റ് എക്സ് അസൈൻ 10 കൊടുത്തു ഇതല്ലേ ഉദ്ദേശിച്ചത് അല്ലേ അല്ലേ okay right. So what should be the output now? What should be the output? Can you compute the output and print? Right. So once again, let's analyze the program. Say here you have this int x assigns 30, that is the global variable. This is the x. It has the value 30 stored in some location, right? Now we are in the main function, and here what I am doing is I am defining a new variable. Int x assigns 10. I am defining a new variable, right? Whenever I am defining a new variable, there should be memory area allocated to that variable, right? This is the local variable x stored in some location 2000. And what is the value of the local variable x? It is 10, right? It is now 10. This is the local variable x, and see, that is because I am defining a new variable int x. I am defining a new variable, and what is the name of the variable? It is x, and x is local to this function, right? Int x assigns 10, and now I am calling this foo, and here I am moving to this foo function, printf %p backslash and x, and the only x this function knows about is the global variable. It doesn't know about the local variable inside the main. It knows only about the global variable x here, right? It knows only about the global variable x here, and it will print the value of the global variable x. What is the value of the global variable x? It is 30 only, right? So the answer will be actually 30. So do you understand this? Does everyone get this? Okay, Nathan. What about others? So these are all tricky things, but C is quite good at doing or handling these tricky uh, characteristics. Right. Okay. If that is the case, let me change this program once again. Here, here also I am defining a local variable. That is also possible, right? So here I am defining something like int x against 50. So what should be the output now? Okay, Ahmed says it is 50. Okay, everyone says it is 50. Right. So let's once again analyze this program. We have this global variable x, which is 30, stored in location 7000. When I come to this main, I have this index assigned 10. So that's the local variable to this main function, and that has the value 10. I am calling this foo function, and here once again I am defining a local variable, right? Index assigned 50. So here I am defining a local variable x, and it has the value 50, may be stored in location 5000, right? And now I am trying to print the value of x. Here there is a slight issue, that is uh, the foo function is trying to print the value of x, and it knows about two x's. The first is the global variable x, which is applicable inside the foo function, and then you have the local variable x, which is also available inside the foo function. Both x's are available inside this foo function, right? The global variable is available. Of course, global variable is available in every function, and then the local variable also is available inside uh, the foo function. And unfortunately, both these variables have the same name x, right? But both these are different variables stored in different locations, right? And then it is trying to print the value of x. And in this case, if you have two variables, one local and one global with the same name, then the local variable gets the preference. Local variable is preferred over global variable. Local is preferred over global. So this means the global variable is simply ignored and the local variable is actually printed here. What is the value of the local variable here? It is 50. So the answer will be 50 here. So if you have a global variable and a local variable with the same name, then the local variable gets the preference inside a function. Do you understand this? Do you get this? Okay. Angel and Amga. Right. So I wanted to explain one more concept here, but that I will refer for the next class. So in today's class, what we have learned are the parameter passing mechanism. We know that C uses a pass by value mechanism for parameter passing to function, and then we have seen different variables, like we understood what a local variable is, and we understood what a global variable is. We understood that a local variable has a life only inside that function, whereas a global variable has a life throughout the program. That is, it is shared in multiple functions, whereas a local variable is available inside that function only, right? Then we have played with different kinds of settings of these local and global variables. So I think we can stop this class here for today. And once again, I will try to upload the video. Those who couldn't listen properly may be able to watch the video later and understand the concept of these functions. This concept of these functions is really, really important. And so with this, we wind up today's class.